question to explain the 2008 HSC Physics paper. This is for Module 6 Inquiry Question 1. So back to charged particles in an electric field and magnetic field. So question 23. Two parallel metal plates in a magnetic field are separated by a distance of d. An electron enters the space between the plates. In question A, it says, on the diagram, indicate with an arrow the direction of the force on the electron due to the magnetic field. Okay, so in this case, I'm going to use the left-hand rule, or what they call the Fermi Rule. So your left hand, the thumb, indicates the current, but for a negative current. In this case, most appropriate for an electron because it's a negative charge. The fingers is the direction of your magnetic field, and your palm is the direction of the force. So if I use my left hand, the electron is moving to the right, so my left thumb is pointing to the right. My fingers are pointing into the page because that's what the crosses represent. So the force is acting down on the electron. So the magnetic field is going to make it kind of curve circularly down in this particular direction. Okay? So down the page is where the force is going. Question B. The strength of the magnetic field is 0.001 and the electron's velocity is that. Calculate the magnitude of the magnetic force on the electron. Okay. So what we can see here is the electron's motion and the magnetic field are perpendicular to each other. So the formula we use is F equals 𝑞𝑣𝐵, where Q is the charge of an electron. Now you do need to use your data sheet to find out the charge of an electron. In this case, it is that, so in this case, because it says just to calculate the magnitude, I don't need to put in a direction. So you can just substitute in the number, like so, minus 19, at a velocity of 2 times 10 to the power of 6, and a magnetic field strength of 0.01 Teslas. Grab your calculator, substitute that in, see what you get. So the value I get at the end is a force of 3.204 times 10 to the power of 16 newtons. That's how you do question B. Moving on to question C. It says, if the distance of separation, so that's the separation between the two plates, like that, is 10 millimeters, calculate the voltage required for the electron to continue a straight path on the plates. Okay. So the idea is the strength of the electric field to allow our electron to go across like this. Now, if we look at where the field is going, this is the positive side, this is the negative side, so it's positive to negative. So according to an electric field, that's going to drag the electron up this way. Okay. If the electron goes straight through, that implies that the force, the magnetic force, and the electric field force are equal to each other. Okay, we already know what the value for B is. If we look at what FE is equal to, FE is equal to QE. Okay, so it's equal to QE. Okay, there's that. And it says the voltage required. So QE, and we also know that E is equal to V over D. So if I substitute all that together, I get 3.04, that's our strength of the field, equals to Q, okay, V over D. So that's what we get here. The charge of the electron hasn't changed. So 3.204 times 10 to the power of 16 divided by the charge of the electron. Again, we're only looking at magnitude here. So 19 equals to our distance, which is 10 times 10 to the minus 3 because it's 10 millimeters, and then voltage. So in order to get rid of this, I times both sides by that number there. So let's put it into our calculator and see what our final voltage will be. Okay, so the final voltage I get, potential difference, is 20 volts. Okay, and that's how you do the question.